We hear about neural networks all the time, but what are they really? How do they work? And why do people say they're the key to artificial intelligence? Welcome to the Technoaivolution Series, where we explore the future of thinking machines. A neural network is a computer system designed to mimic the way the human brain processes information. These systems are a subset of machine learning and are at the core of deep learning algorithms. They are designed to recognize patterns and interpret data in a way that is similar to the human brain. It's made up of nodes, or as we like to call them, artificial neurons, that are connected to each other in layers. These layers include an input layer, one or more hidden layers, and an output layer. Each node in a layer is connected to nodes in the subsequent layer, forming a network of interconnected neurons. Just like your brain takes in input through your senses, a neural network takes in data. This data can be anything from images and sounds to text and numerical values. The input layer receives this data and passes it on to the hidden layers for processing. It processes that data through connections, makes decisions, and gives an output. The hidden layers perform complex computations on the data, extracting features and patterns. Finally, the output layer produces the result, which could be a classification, a prediction, or any other form of decision based on the processed data. Neural networks are powerful tools that are transforming industries by enabling machines to learn from data and make intelligent decisions. Most neural networks have three main parts. The input layer, which is where the data enters the network. This layer is responsible for receiving the initial information and passing it on to the next stage of the network. Then there are one or more hidden layers. These layers are where the magic happens. They process the input data through a series of transformations, extracting features and patterns that are not immediately obvious. Each hidden layer can have multiple neurons, and the more layers there are, the deeper the network, hence the term deep learning. Finally, we have the output layer. This is where the network's predictions or classifications are produced. Each neuron in this layer represents a possible outcome or category. The data flows through the network, and each connection between neurons has a weight, which determines the strength or importance of the signal being passed. As the network learns, it adjusts these weights based on feedback from the output. This process, known as training, involves using algorithms to minimize the error between the predicted output and the actual result. The goal is to make the network as accurate as possible in its predictions. Training can be a complex and time-consuming process, but it's essential for creating effective neural networks. By continuously adjusting the weights and fine-tuning the network, we can achieve remarkable levels of accuracy and performance in tasks ranging from image recognition to natural language processing. Let's say we're teaching a neural network to recognize numbers. This process involves feeding the network a vast amount of data, specifically images of handwritten digits. Each image is paired with a label that tells the network what number it represents. We show it thousands of images of handwritten digits, each with a label. At first it's bad, it makes random guesses. The network doesn't understand the patterns yet, so its initial attempts are often incorrect. This is a normal part of the learning process. But over time, through trial and error, the network improves. Each time it makes a mistake, it adjusts its internal parameters slightly to reduce the error next time. This iterative process is known as training. The more data it processes, the better it gets at recognizing the patterns. Eventually it gets so good it can recognize a 3 even if it's messy or stylized. This ability to generalize from the training data to new, unseen examples is what makes neural networks so powerful. They can learn to identify complex patterns and make accurate predictions, even in challenging conditions. Neural networks are behind some of the most powerful AI systems today. Siri and Alexa, self-driving cars, medical diagnosis tools, and even deepfake generators. They're flexible, scalable, and once trained properly, surprisingly accurate. But neural networks aren't perfect. They can be biased, confusing, and are often described as black boxes because we don't always understand why they make the decisions they do. Powerful, but mysterious. Whether you're a student, a creator, or just curious, understanding neural networks gives you a window into the tech shaping our future. They're not just math models. They're the building blocks of a new kind of intelligence. This was Technoaivolution. Your own brain right now is doing something neural networks they could do, making meaning from all this, and that's what separates us from machines. For now, thanks for sticking with us through this episode. If you made it this far, you're officially part of the Technoaivolution. Please like and subscribe to our channel for more content.